Welcome to my channel, DNA.12 Education. Hello students, welcome again to my channel DNA.12 Education. Students, welcome again to L-level math. Our topic today is differentiation. Level math for Cambridge International, differentiation part 2. Okay, students, for the previous video, we learned about differentiation part 1. At that video, we learned about the first principle of differentiation and the first derivative. Okay, students, today you're going to A-level math differentiation part 2 about the application of differentiation. Okay, students, application of differentiation. There are many applications of differentiation, but for this video, we are going to talk and discuss 3 of the application of differentiation. The first is to find the gradient m. The first application of differentiation is to find the gradient m. The gradient m will be satisfied by dy over dx over the first derivative equal m. So this is the first requirement to find the gradient m. So the gradient m will be satisfied when the first derivative equal m. Okay, now we're going to the first example. What is the gradient of the curve y equal 2x cubed at the point 1, 2? What is the gradient of the curve of the function y equal 2x to the power of 3 at the point 1, 2? Okay, students, now we're going to start answering this question. How to answer this one? Students, to find the gradient, we will be satisfied by the first derivative equal m. The function is y equals to 2x to the power of 3. Okay, when we go to the first derivative, dy over dx or y-axis equal 6x squared, right? Do you still remember how to differentiate of the function? Yes, very good. Okay, students. dy over dx, the first differentiation is 3 times 2, it's 1, right? You have to multiply the coefficient, and then x, and the power will be reduced by 1. 3 minus 1. So automatically, we'll find the first derivative is 6x squared. Very easy, right? Okay, students, the gradient will be satisfied by the first derivative. Means y-axis equal m equal 6x squared. Okay. Okay. The point is 1 comma 2, right? When x equal 1, so we have to insert x equal 1 to this first derivative. Okay. So we'll find m equal 6 times in the bracket 1 squared. So we'll find the gradient is 6. That's very easy, right? So the first applications of the differentiation is to find the gradient. Very easy. Okay? Okay. Look at the graph on the screen. This is the function of y equal to x cubed. Okay? This is the function y equal fx 2x cubed. Okay, this is the function of y equal fx equal to x to the power 3. So what is the gradient? Okay, students, when x equal 1, okay, this is x equal 1. You can see on the screen, this is x equal 1, right? Okay. When x equal 1 go to the vertical line and then intersect the graph, we'll find this is the point of the gradient, m. Yes, students? This point is 1 comma 2. 1 comma 2. Okay, this is the point, right? Okay, now we are going to the gradient. How to draw the gradient at the point 1 comma 2. This is the gradient, right? How to read the gradient by this graph? Okay, that's very easy. As I mentioned before, the gradient is delta y over delta x, or the gradient is dy over dx. So when we have at this point, for dy is 6 steps, and for dx is 1 step, right? So the gradient m dy over dx, or change in y over change in x, we'll find that change in y divided by change in x is 6 over 1. So we'll find the gradient is 6. That's very easy, right? So m equals 6 is proven. Is it clear to everyone how to find the gradient by using differentiation? Okay, students, this is the first application of differentiation, right? Okay, students, now we go to the second application of differentiation. The second application of differentiation or derivative is we use the derivative to determine the maximum and minimum values of particular function. We use the derivative to determine the maximum and minimum values of particular function. The maximum and minimum values will be satisfied by dy over dx, or the first derivative, equal 0. Once again, the maximum and the minimum values of the particular function will be satisfied by dy over dx equal y-accent, or the first derivative, equal 0. Students, the application of differentiation for finding the maximum and minimum values of the particular function, we can find in two functions. The first is quadratic functions, and the second is cubic functions. That's commonly we find the case in mathematics problems. For the quadratic function, okay, for the quadratic function, either maximum or minimum. Once again, students, for quadratic function, when the first derivative equals 0, we'll find either maximum or minimum point. Once again, for quadratic function, we'll find either maximum or minimum point. So you have to understand, for the quadratic functions consists of one maximum or one minimum, not both. So either maximum or minimum point. How to differ the function? That's very easy. I want to review this function again for the maximum or minimum point. For the maximum point, we'll find the function like this. This one, the type of the maximum point. The parabolic is open downward. We call maximum point. But for this type, this parabolic is open upward. We call this one minimum point. Do you still remember about this function? Very good. For the quadratic function, as we know, the function formula is fx equal ax squared plus bx plus c. Right? So the maximum point will be satisfied by the first derivative is 0. And for a minimum point, the first derivative is 0. So for both this type, will be satisfied by first derivative equals to 0. For the maximum type, or the maximum point, we'll find the characteristic of the maximum graph when a less than 0. But for the minimum point, when a more than 0. Is it clear to you, everyone? Very clear, right? So this is the characteristic of the quadratic function and the application of differentiation for the quadratic function. Okay, students, what about for cubic function? For a cubic function, there is a little bit difference than for quadratic function. For the cubic function, maximum and minimum point, for both we'll find maximum and minimum point for cubic function. So you have to understand, for the cubic function, there is one maximum point and one minimum point, and actually there is one point of inflection. Okay, now we go to the stage of the graph. Students, this is the case of the graph for cubic function. For example, this one. Let's see one. This one is maximum point, and this one is minimum point. Okay, give it to you. And this point is point of inflection. Point of inflection. Point of inflection is point where the gradient of the curve stops falling and starts rising, or vice versa. Point of inflection is point where the gradient of the curve stops falling and starts rising, or vice versa. Okay, is it clear to everyone? Okay, now I want to write again the function of the cubic, this one, right? Ax cubed plus bx squared plus cx plus d. Okay. Is it clear to you how to differ quadratic function and cubic function? And what is the difference of application of differentiation? Okay, students, for the cubic function, maximum and minimum will be satisfied by the first derivative is 0. Okay, so the maximum or minimum point will be satisfied by the first derivative, or y-axis equals 0. But point of inflection will be satisfied by d2y over dx squared equals 0. Once again, for the cubic function, maximum and minimum point will be satisfied by the first derivative equals 0. But point of inflection will be satisfied by d2y over dx squared equals 0. Commonly, we call this one second derivative, or y double accent. Is it clear to everyone? Okay. Students, now we go to the next topic, and how to apply the application of differentiation. Application of differentiation for quadratic function. Okay, look at this example. Find the dimension of rectangle with perimeter 1000 meters so that the area of the rectangle is maximum. Find the dimension of rectangle with perimeter 1000 meters so that the area of rectangle is a maximum. This is the solution, everyone. Okay, students, this topic is about maximum or minimum point. But based on the question, it's very, very clear that this rectangle will find the maximum point. So the maximum point will be satisfied by the first derivative, or the first derivative, or y-axis equals 0. Okay, now we go to the solution. Let the length of the rectangle be x meter, the width be y meter, and the area be a meter squared. Okay, this is the sketch of the rectangle with perimeter 1000 meters. Okay, the length is x and the width is y. As we know, the perimeter is 2x plus 2y equals to 1000 meters. You can simplify by dividing by 2. It will be fine. X plus y equals 500. Now we found x plus y equals to 500 meters. Right? Okay, what is the area formula? Area formula A in x equals x times y. Right? By substituting y equals 500 minus x, once again, by substituting y equals 500 minus x and insert to the y, we'll find that the formula of A in x is x times 500 minus x. We can simplify that the area in x is 500x minus x squared. Very easy, right? Okay, students, now we go to the maximum point. The maximum point will be satisfied by the first derivative of the area equals to 0. We'll find that the first accent or the first derivative is 500 minus 2x. Do you understand, students, how to find that? Yes. dy to dx is 500 minus 2x. Right? Next, because the satisfaction of the maximum point is dy over dx equals 0, okay, this one. Right? We'll find that the x is 250 meters. Okay, students, now what is the dimension? So x is 250 meters and automatically y is 500 minus x. Okay? By inserting x equals 150 to x, we will find that the dimension of y is 500 minus 250. We found y is 250 meters as well. That's the dimension of this rectangle. Students, what about the question? Can you find the maximum area? Of course. So the maximum area A in x is x times y. X is 250 meters and y is 250 meters as well. You'll find that 62,500 meters square. 62,500 meters square. That's the maximum area. Is it clear to everyone? Okay, that's very clear. Okay, students, now we go to the second application of the differentiation of cubic function. A curve whose equation is y equals 4x cubed minus 3x squared minus 6x has stationary points. Stationary points means maximum point and minimum point. That's stationary point. Okay, once again, students, stationary points means maximum point and minimum point. That's stationary point. Find the stationary point. Find the stationary point. Determine the nature of this point. And what is the solution? That's very easy, everyone. Okay, students, now we go to the solution of this question. Stationary point, yeah, will be satisfied by y accent equals 0 or dy over dx equals 0 for the first derivative. Students, the function is 4x to the power of 3 minus 3x squared minus 6x, right? So dy over dx, we'll find that 12x squared minus 6x minus 6. Very easy, right? So we find this one. Next, by dividing by this equation by 6, we'll find the simple equation. It will be 2x squared minus x minus 1. Okay? Divided by 6. So, what's the next that are we going to do for? All right, we have to factorize. 2x plus 1 in the bracket and x minus 1 in the bracket equals 0. We'll find the first x is minus 0.5 and x2 is 1. Okay, can you find y1? Yes, 1.75 and y2 is minus 5. Oh, students, how you know that y is 1.75 and y is minus 5? That's very easy. Where function is y is 4x to the power of 3 minus 3x squared minus 6x. When x1 is minus 0.5, you can insert to the x. Okay, so y equals 4 minus 0.5 to the power of 3 minus 3 minus 0.5 squared minus 6 times minus 0.5. You'll find that y equals 1.75. So this is the answer. We call this one y1. What about x2 equal 1? By the same way, you can insert x2 equal 1 to this function again. Okay, so you'll find that y2 is minus 5. Is it clear to everyone? Okay, next. How to find either maximum or minimum points? Okay, to find either maximum or minimum points, will be satisfied by the 2y over the x squared. We call this one the second derivative. Okay, the second derivative. Once again, to find either maximum or minimum points, will be satisfied by the 2y over the x squared, or the second derivative. We have to examine x1 minus 0.5 and x2 equal 1. So x1 is minus 0.5 and x2 equal 1 will be examined to the 2y over the x squared. Clear to everyone? Next, the 2y over the x squared equal 24x minus 6. Is it clear to everyone? dy over dx equal 12x squared minus 6x minus 6. So d2y over dx squared, the second derivative, so it's 1, right? 24x minus 6. So that's why we found this one. Clear to everyone? Next, when x equal minus 0.5, we have to insert minus 0.5 to the function or to the second derivative. Okay. We can insert to the function, okay, here, right? We'll find that d2y over dx squared is minus 18. When you found d2y over dx squared is minus 18, means less than 0. So when the value less than 0 means we call that the maximum point. With the same way, we have to insert x equal 1 to d2y over the x squared. d2y over dx squared is 24 times 1 minus 6. We found that d2y over dx squared is 18. The conclusion is the value of d2y over dx squared when x equal 1 is 18 is more than 0. When we have the value more than 0 means we call that minimum point. Is it clear to everyone how to find either maximum or minimum points for cubic function? Very good. Okay, so let's go. The application of differentiation for the cubic function. Okay. All the summary we can find on this sketch of the graph. Look at this graph. Y equal 4x cubed minus 3x squared minus 6x. This is the function. Y equal 4x to the power 3 minus 3x squared minus 6x. This is the function. This is the graph. When x equal to minus 0.5, we got that d2y over the x squared is minus 18. We found this one before. Less than 0 means a maximum point. But when x equal 1, and by inserting this x equal 1 to d2y over the x squared, we found that d2y over the x squared, the value is 18. We call this one minimum point. The third one. Less than 0 means maximum point. More than 0 means minimum point on this given function. Okay, look at the graph. Where is the position of maximum point and where is the minimum point? The maximum point is here. Get you? When x equal minus 0.5 here, minus 0.5, right? We got the maximum point is here, right? This is the value. Okay, this is the maximum point. Next, what about the minimum point? The minimum point will be satisfied by d2y over the x squared equal 18. So it means more than 0 means minimum point. And this minimum point will be satisfied by x equal 1. Right, everyone? Okay, this is the minimum point. Clear to everyone? Very good. Now is the last point of inflection. Point of inflection is point where the gradient of the curve stops falling and starts raising, or vice versa. Once again, point of inflection is point where the gradient of the curve stops falling and starts raising, or vice versa. Point of inflection will be satisfied when d2y over the x squared equal to 0. These are the requirements for the point of inflection. So d2y over the x squared equals 24 minus 6 equals to 0. We found that x is 0.25. So this is the position of x equals 0.25, right? Look at the yellow dot. So when x equals 0.25, okay, we found here is the point of inflection. So point of inflection is point where the gradient of the curve starts falling and starts raising, or vice versa. So is it clear to you, everyone? How about application of differentiation for equal function is done? Very clear, right? So the application of the differentiation for this video, the first is to find the gradient will be satisfied when dy over dx equals m. And the second application for the graph is for the stationary point or maximum or minimum point will be satisfied when dy over dx equals 0. And the third is point of inflection will be satisfied by d2y over dx squared equals to 0. Okay, so then that's all about the application of differentiation. Okay, students, to make sure you are clear about this material, now we go to exercises. Good luck, everyone.